Hey, welcome back. This is now 7.5 in Math 0965, and today we're going to deal with complex rational expressions, which are basically just fractions on steroids. Okay, so the way we're going to handle it is via two different methods. So you can do whichever method you please. Okay, so method one, what we're going to do is kind of simplify the top and bottom. And then step two, we'll rewrite division as multiplication. Okay. Okay. I'm just going to take a second and make sure I know where my video quiz is. Okay. So let's take a look at what we're dealing with. So this is problem 2 from the book. Basically, you have fractions within other fractions. So what I'm writing now is really the numerator of a bigger fraction. Okay, so 1/3 plus 1/4 all over 1/3 plus 1/6. Okay, so what does that method mean? Simplify the top and bottom. Well, that means in the top we're going to find a common denominator and add the numerators over the common denominator, and we're going to do that in the same thing in the bottom. Okay, so in the top I need a common denominator, so I'm going to have to multiply this top and bottom by 4. I accidentally wrote 3 there. Times 4 times 4. And the other guy I have to multiply top and bottom by 3. Okay. And the denominator, the first fraction, we can get a common denominator by just multiplying top and bottom of that thing by 2. Then we'll have a 6. Okay, so let's see what we get. In the top here, I got 4/12 plus 3/12. And then the bottom, I have 2 6s plus 1 6s. Okay. I'm not done. I want to add those numerators over the common denominators. So I'll have 7/12. 4 plus 3 is 7. All over 2 plus 1 is 3. Over 6. And then lastly, I'm going to rewrite this as division. So literally, I think of this fraction bar in the middle as divided by. Okay, so I just think of this is basically division. So I can rewrite it as 7/12 divided by 3/6. And then the second step here in my method, rewrite division as multiplication. That's what I'm going to do now. So I have 7/12 times 6/3. Okay. And now hopefully we could do this using, methods from arithmetic. I like the factor, so 6 is really 3 times 2. And then downstairs, 12 is really 2 times 2 times 3. And then we have a 3 here. And then I can remove common factors. And it looks like I got 7/6 for my final answer. Okay. Okay, so that's the idea here. You may even remember from order of operations, please excuse my dear Aunt Sally. This P stood for parentheses, but not only that, it also stood for fraction bars. So before we do anything, what we're kind of doing here in this method is simplifying the top part completely and simplifying the bottom part completely. Okay, so this also includes fraction bars. People who haven't taken algebra in a very, very long time won't remember that fact. They just think, please excuse the parentheses, exponents, multiplication, division. Okay, let me move on. Let's look at some more examples here. So I have 8 plus 3 over x divided by 1 minus 7 over x. Okay, I'm going to do the same process. You can think of 8 as, okay, that's the same as 8 over 1, right? Plus 3 over x. And then the same thing for 1 in the denominator. 1 is the same as 1 over 1. And then I'm going to multiply in my to get my common denominator. So in the numerator, the first fraction, its denominator is missing an x. Okay. And in the denominator, the 1 over 1, we need to get an x in its denominator as well. Okay. And then we should have a common denominator for both. Okay, so I have 8x over x plus 3 over x all over x minus 7 over x. Okay, I'm gonna rewrite this. The numerator here, add up the numerators over the common denominator. It's kind of weird saying it out loud. It's like you have to add the numerators of the fractions in the numerator. It's weird. Anyways, I hope you can understand what I mean. Anyways, there's the result of adding and subtracting the numerators over the common denominator. Now I want to rewrite it. Rewrite this as division, or using the division symbol. And then finally, you could rewrite it as multiplication. Okay. So 8x plus 3 all over x times x all over x minus 3. And we have those as sort of independent factors. So 8x plus 3 times x all over x times the x minus 3. You can then see, all right, there's a common factor of x in the top and bottom, so I can remove those, kind of replace them with 1s. And then finally, all I have left is the factor of 8x plus 3 in the numerator and the factor of x minus 3 in the denominator. Okay. Oh, did I screw something up? It should be x minus 7, sorry. Down here. I don't know where I got the 3 from, folks. I apologize. Okay, so this will be x minus 7, and then this will be x minus 7. Okay. So I got a couple more. The more, we want to get more and more complicated. So like probably about 4 more, getting more and more complicated as we go. And then we'll move on to the method 2. So anyways, we have 3 over x plus x over 3 in our numerator. The denominator, x over 3 minus 3 over x. Okay. Okay, so in the numerator, common denominator, the fraction on the left here is missing a factor of 3. And the fraction on the right is missing a factor of x. And the denominator, it's kind of the same spiel. The first denominator is missing a factor of x, so top and bottom by x. The second denominator is missing a factor of 3, okay, top and bottom by 3. Okay, so I'll have 9 over 3x plus x squared over 3x all over x squared over 3x minus 9 all over 3x. Combining numerators over common denominators, 9 plus x squared all over 3x all over x squared minus 9 all over 3x. Okay. Rewrite it as sort of a big division issue problem. So put the big division symbol in there. X squared minus 9 over 3x. And then I'm going to rewrite the division as multiplication finally. So 9 plus x squared over 3x times 3x over x squared minus 9. Multiply, and then we're going to remove common factors. 9 plus x squared is prime. That's a sum of squares. 1 times 3x. Downstairs we have a 3x. You could factor the x squared minus 9 because it is a difference of squares, but it's not going to really matter because you're not going to get a nice cancellation of any sorts. You will get the 3x's to cancel, okay, so good news there, but nothing else. Okay, so you end up with that factor of 9 plus x squared. Whoops, I see a big fat mistake right there. Ooh, get rid of that guy, right? All right, and then the denominator, you could leave it factored out, or you could just write the x squared minus 9. Okay, either way is fine. You may say these are opposites. This equals -1. No, you'd be wrong. To be opposites in the numerator, you would need -x squared. Everything has to have opposite signs. So if you added the numerator to the denominator, they would equal 0. Okay, so this one can't do that. Okay, let's look at 26. So I have 1 over x plus 1 over y. So we get multiple variables in some of these problems. All over 1 over x minus 1 over y. Okay. Again, these aren't opposites, right? You would think, well, maybe I can reduce this just to -1. That's not the case. You would need a -1 over x here in the numerator, but it's not the case. Okay, so anyways, we need the common denominators. So the first fraction in the numerator is missing a factor of y in its denominator. The second fraction then is missing a factor of x. Okay. Moving to the denominator, the first fraction is missing a factor of y, and then likewise the second fraction is missing a factor of x. I can go ahead now and kind of rewrite stuff, see where I'm at. And I got my common denominator apparently. I kind of just want to jump to the conclusion. I'll try not to. Y over xy minus x over xy. Okay, and now combine numerators over common denominators. Y plus x all over xy all over y minus x all over xy. Turn it into division. I mean, it is technically division, but just rewrite the expression as in this new form. All right, so divided by y minus x all over xy. Hopefully I didn't butcher that too much. You can read that. Now rewrite it as multiplication. Y plus x over xy times xy all over y minus x. Okay, so I'm getting y plus x times y, or just xy if you'd rather, all over x times y minus x. And then we see some small cancellations here and here. Again, the y plus x and the y minus x are not opposites. You can't replace that with a -1. You're just going to be left with it. Y plus x all over y minus x. Okay. Okay. Getting more and more gruesome looking. Let's look at number 34. So we have 1 over x minus 2 all over 1 minus 1 all over x minus 2. Let's make this the video quiz for the day. I think this is challenging and would be worth having you write it out for us. Okay, let me mark down on my notes. So this is number 7.5, number 34 is the video quiz. Video quiz. So hopefully that's clear. Okay. And the numerator, I'm kind of done. There's not much to do there. It's already one fraction. The denominator, though, I need to rewrite it. So the number 1 you can think of as 1 over 1, and then minus 1 over x minus 2. Then I can get my common denominator, so I can multiply the denominator of this guy by x minus 2, and then the numerator, again, by x minus 2. Okay. So I get 1 over x minus 2 all over x minus 2 over x minus 2 minus 1 all over x minus 2. And then I'm going to subtract the numerators over the common denominator. So I get x minus 2 minus 1 all over x minus 2. So I have 1 all over x minus 2 all over x minus 2 minus 1 is x minus 3 over x minus 2. And then I'm going to rewrite this whole thing as division with the division symbol, right? So it's 1 all over x minus 2 divided by x minus 3 over x minus 2. And then I'm going to rewrite it as multiplication. Okay, so 1 over x minus 2 times x minus 2 all over x minus 3. You can already see there's going to be a nice little cancellation with this factor of x minus 2. If you wish, you can kind of put it in parentheses so it looks even more similar. But it's, the x minus 2's cancel. You're left with 1 all over 1 times x minus 3, which is just x minus 3, and then that's it. Okay, one more, and then we'll move on to the method 2, the second method here. So this is problem 40. 3 over x plus 2 minus 3 over x minus 2 all over, what is that? I'm trying to read my handwriting. 5 all over x squared minus 4. There we go. Okay, so the denominator this time is kind of done, and you need to get some common denominators here in the numerator. So I need to multiply the first guy. It's missing an x minus 2, so up and down by x minus 2. And the second guy is missing an x plus 2, so top and bottom by x plus 2. So in the first numerator, or let's just rewrite everything, right? It's kind of not a bad idea. So 3 times x minus 2 all over x plus 2 times x minus 2 minus 3 times x plus 2 all over x minus 2 times x plus 2 all over 5 all over x squared minus 4. Okay, now let's combine the numerators over the common denominator in the numerator. Plus 2 times x minus 2 all over 5 all over x squared minus 4. Okay, I need to do some distribution here, so I'll end up with 3x minus 6, and then distribute this guy, minus 3x minus 6 all over x plus 2 times x minus 2, and then that's all over 5 all over x squared minus 4. Whew. All right, then the numerator, 3x minus 3x is 0, so you get a minus 12. 2 times x minus 2 all over 5 all over x squared minus 4. Then we'll rewrite it with the division symbol, so 12 all over x plus 2 times x minus 2 times, or whoops, divided by 5 all over x squared minus 4. Okay. And then rewrite the division as multiplication, so I got minus 12 all over x plus 2 x minus 2 times x squared minus 4 all over 5. Multiply out, factor along the way, so I get 12 times x squared minus 4 is a difference of squares, so we can factor that. And we get some nice cancellations happening. And so the x plus 2's are gone, the x minus 2's are gone, you just left with negative 12 over 5. Okay. Okay, method 2, folks. Let's try method 2. So, in my personal opinion, method 2 is a bit quicker, but I use both of them. I don't really exclusively just do one or the other. And the way it's going to work is to multiply top and bottom by the LCD of all of the little fractions involved. Okay, so multiply, I'll just write mult, top and bottom by the LCD. Okay, so let's see what I mean by that. Here's problem 6. You have 1/2 minus 1/4 all over 3/8 plus 1/16. Okay, so when I say the LCD, I mean the LCD of all 4 of these fractions. Okay, so not just 8, like the LCD of the 2 fractions in the numerator. That would just be, well, it would be 4. It wouldn't even be 8, right? But the 4 wouldn't work in the denominator, and we want something that's going to kind of cancel out all of the denominators. So the number, I mean, you can imagine in your head, you're like trying to add 1/2, 1/4, 3/8, and 1/16. Okay, what would have to be the common denominator of all of these together in order to add those up? Well, you would have to use 16, right? 8 wouldn't be big enough. You'd have to, so I'd have to multiply top and bottom of this guy by 8. Have to multiply top and bottom of this guy by 4. Top and bottom of this guy by 2. And then I would have a common denominator of 16, right? Okay, so that's the number you want to multiply top and bottom by. So my first step is literally just to do that. Okay, so I'm going to multiply top by 16, and if you do that to the top, you have to do that to the bottom by 16. Okay, and then you're distributing. Okay, so you'll get 16 over 1 times, over here to the side, you can think of it 16 over 1 times 1 over 2. Okay, that's the same as 16 halves, which is, of course, 8. So that first distribution gives me an 8 minus 16 over 1 times 1 over 4. I mean, you could literally just go like this. 4 goes in the 16 4 times. Leaves you a 1 there. 4 times 1 is 4. 1 times 1 is 1. So it's just 4. Okay, 8 minus 4. All over and distribute here. So 16 over 1 times 3 over 8, if you need to. 16 is 2 times 8. And then there's the 3 all over the 8, so the 8 goes in there. It's just 6, right? The first one's 6. And then 16 over 1 times 1 over 16. What is that? That's just 1, right? So we'll have plus 1. Okay, 8 minus 4 is 4. All over 6 plus 1 is 7. And that'll be it. Okay. So it's a little more direct, but a little quicker, but you do have to figure out that LCD thing. Okay. Maybe that's difficult for some people. Okay, so anyways, 4 minus 7 over y. Butchered that. All over 3 minus 2 over y. So again, it's this, what is the common denominator of all of these fractions? Right? As if I were going to add them all together. So this guy would need a y and top and bottom. This guy would need a y. So the common denominator becomes y, right? So I'll multiply top and bottom by y. Okay, so here 4 times y is just 4y. When you multiply these together, the y's will cancel, and you'll just be left with minus 7. Okay, if you don't believe me, you could kind of do that over here. Y over 1 times negative 7 over y. You would get negative 7y over y, and then the y's would cancel, and you get negative 7 over 1, which is just negative 7. Okay. Then this guy, y times the 3 just gives you the 3y, and then for similar reasons, you just get minus 2, right? If you don't believe me, y, which is the same as y over 1, times negative 2 over y will be negative 2y all over y. Then the y's will cancel, and you just get negative 2. Okay? Let's try number 18. So 1 plus 2 over x all over 1 minus 4 over x squared. So any guesses on the LCD? Anybody want to guess? Well, x won't be good enough, right? You need x squared. Multiply top and bottom by x squared. Okay, so on the top, when you distribute this, x squared times 1 is just x squared. And then x squared times 2 over x, if you think about it over here, x squared is really x squared over 1 times 2 over x. X will go into x squared, or if you're rather doing the factoring, so let's be consistent with how I've taught you. 2 over x. This will equal 2 times x all over x. And then one of the x's will cancel, and you're just left with 2x. Right? All over, if you distribute this guy, you'll get x squared, and then minus, what? Well, again, go x squared over 1 times negative 4 over x squared. You'll just be left with negative 4, right? Because these x squares are going to divide out. So minus 4. And then you look for any simplifications, and this guy looks like it could possibly have one. You factor out an x from the numerator, get x plus 2. denominator is a difference of squares, x plus 2 times x minus 2. And then we can remove common factors. So I can remove common factor of x plus 2. And I'm left with x over x minus 2. Okay. Okay. Just a couple more, and then we'll switch over to my math lab. Okay. Where the heck is my math lab? Person sign in. Oh, 1965. I just want to. I had not navigated there. Assignments, and we're on 7.5. Let me just sort of get that set up. Okay, just two more. So we want to make sure we cover all of our bases here. This one a little more complicated because it has three terms in the numerator and denominator. So x plus 9 minus 7 over x all over x minus 6 plus 4 over x. Okay, so any guesses as to what we need to multiply by? Well, the first two guys aren't fractions, so there's nothing you really need to multiply to unlock those, so to speak. But this third guy's the troublemaker, right? The 7 over x, and if you multiply it by x, that will get rid of that fraction. And the same for the denominator. Okay, so but now I need to, distribute. So the first distribution gives me x squared, and then plus 9x, and then minus 7, right? Because you'll have x times 7 over x, which is basically x over 1 times 7 over x, which will be 7x over x. And of course, then the x's cancel and you get 7. Okay. And downstairs, we'll have x squared minus 6x, and then plus 4, right? Because if you multiply the x times 4 over x, you'll get 4x over x. And then the x's will cancel, and you're just left with 4. Okay. Okay. We can't factor the numerator at all. The only possibilities would be 7 and 1 for the last terms, and then you would never get that to add to 9. So you're kind of stuck. Okay, let's look at 38, and then we'll go to my math lab. 2 all over x cubed y plus 5 all over xy to the 4th. And then that will be all divided by 5 all over x cubed y minus 3 all over xy. Okay. Okay, so again, you kind of think of it like, what would be the common denominator of all these fractions? You would need an x cubed, right? And you would also need a y to the 4th. And then that will do it. Okay, so in the first distribution in the numerator, this times this, the x cubes will cancel, and then it'll be y to the 4th over y, so you just end up with y to the 3rd. So you get 2 at y to the 3rd. The second distribution, you'll have x cubed over x, so just x squared, 5x squared, and then y to the 4th over y to the 4th is just 1, so the y to the 4ths cancel. Then in the denominator, in the first distribution, the x cubes will cancel. Then you'll have y to the 4th over y, so it'll just be y cubed, and then don't forget the 5. In the second distribution, you'll have x cubed over x, so just x squared. Of course, we have the minus 3 as well. And then y to the 4th over y, so you just have y cubed. Okay. And then you think about simplifying. There's nothing to simplify in this case, though, so you're kind of stuck. Right. So that's really, in my opinion, as hard as they get. And you may have to write out some of those distributions in your notes over here. So like, 2 all over x cubed y times x cubed y to the 4th. That would be this first distribution here. You can pretend this is over 1. And you get 2x cubed y to the 4th all over x cubed y. So the x cubes divide out. And then you're left with 2y to the fourth over y. Y to the fourth just means there's 4 y's, but you can subtract the exponents. So there's multiple ways of kind of attacking the problem, but if nothing else, you can think of it that way, all over y, and then one of those cancels, so you end up with 2y cubed over 1, which is 2y cubed. Okay, so you may have a bit of work to do. Let's get into my math lab and see what kind of nonsense you're in for. Okay, so this one, we'll look at that one. Oh yeah, we'll look at that one, and I think we'll start with that one. Okay, so some more complicated examples from my math lab. Move that out of the way. All right, I'm going to begin kind of by factoring that denominator at least a little bit, rather than just blindly copying it out again. So I got x minus, looks like 5, or x plus 5, and then x minus 7, minus 1 all over the x plus 5, then all over 1 all over x minus 7 plus 1. Okay, so I need to multiply. I'm going to use the second method. So I need to multiply everything to get rid of those denominators. So I need to get rid of the x plus 5. So you kind of think, okay, I need to multiply top and bottom by x plus 5. And I also need to get rid of that x minus 7. So I'm going to multiply top and bottom by x minus 7. Okay. So in this first distribution, the denominators will completely cancel, right? Because you're going to have 8 times x plus 5 times x minus 7 over x plus 5 times x minus 7. And the x plus 5s times x minus 7s will cancel. So you just have 8. And then minus the x plus 5s will cancel in the second distribution here. And you'll just be left with 1 times x minus 7. Or if you'd rather, just x minus 7. Okay? We're going to have to distribute that negative. Down below, in our first distribution, the x minus 7s will cancel. And then in our second distribution, there's no cancellation. So for the first distribution, x minus 7s cancel, you're left with x plus 5. And then plus no cancellation, right? So x plus 5, x minus 7 times 1, but we can just write it that way. Okay, now we start simplifying a little bit. So I have 8 distributing the negative. I get minus x plus 7 all over x plus 5. And I'm going to go ahead and FOIL this part. So x squared minus 7x plus 5x is minus 2x, and then minus 35. So I have 7 plus 8 is 15 minus x all over this x squared minus x, so negative 2x plus x is minus x, and then minus 35 plus 5 is minus 30. And then I don't think I can get any nice cancellations to pop out. Okay, so I'm just going to write that in for my answer. Fraction 15 minus x over x squared, arrow minus x minus 30. Drum roll, yay. Okay, so what is that negative exponent? So that's just one of the old exponent rules. Say if I have a to the negative x, that's the same thing as 1 all over a to the x. The negative 1, so if you have like a to the negative 1, that's the same as 1 over a to the 1. And technically all numbers have an exponent of 1, but you never see it. It's just 8 to the 1 is the same as 8. So 1 over a is just the same as 1 over a to the first power is 1 over a. Okay, long story short. Okay, so let's see how to handle this scenario. Okay, so I'm going to rewrite this stuff. The first guy is the same as 1 over x to the positive 1, or 1 over x. The second guy will be 1 all over, and you just take the entire thingamajig here, this entire binomial, and plop it in the denominator. So it would be x to the 6 to the first power, but of course, again, we're not going to write this first power. It's not necessary. Then all over 6. Okay, now I'm finding my common denominator. So this guy's missing an x plus 6 on the top and bottom. This guy's missing an x on the top and bottom. And I'm going to use this the first method to simplify this. Anyways, you'll have x plus 6 over x times x plus 6 minus x all over x times x plus 6 all over 6. So this will equal x plus 6 minus x all over x times x plus 6 all over 6. And that the x's will cancel, and you get 6 all over x times x plus 6 divided by 6. So let's just rewrite that. 6 all over x times x plus 6 divided by 6. And then you can rewrite that as multiplication. So 6 all over x times x plus 6 times 1 over 6. And you could just simplify right here if you want to. I mean, technically it's just, extend the little fraction bar and put some multiplication symbols in there. You'll see the 6's divide out. So in the numerator, you're just left with 1, and the denominator, x times x plus 6. Okay, so no big deal. It's just sometimes you don't have a lot of experience with the weird negative exponents. So hopefully, if you did have a question, I just answered it. Okay. Next. Okay, so it looks like here we have a complex fraction and then minus the number 1. Okay, so I need to simplify this complex fraction. I'm going to use the second method to do that. If you multiply top and bottom by x, that will get rid of the problem. Okay, so in the numerator, I got x times 1 is x. In the denominator, I'll have x times 1, which is x, minus x times 3 over x. Okay, so what would that be? X times negative 3 over x. X is the same as x over 1, so it would be like negative 3 all over x times 1 is x, and then you can remove the x's, you get negative 3. Right? So minus 3, and then minus this 1 here. Okay, so I need a common denominator for both of these terms. I can think of 1 as 1 over 1, and then multiply top and bottom by x minus 3. Okay, so I'll have this equaling x over x minus 3 minus x minus 3 all over x minus 3. And then you can rewrite that as x minus parentheses x minus 3 all over x minus 3. I mean, I didn't need the parentheses at that point. I was just being a bit redundant. So, but you do need them here, because now you're going to need to distribute this negative. You'll have x over x minus 3 minus x plus 3. Sorry, x minus x plus 3 over x minus 3. Then the x's cancel, and you're just with 3 over x minus 3. Okay. It just seems a little bit extra work there on that one. 3 all over x minus 3. Check that guy. Yay. So this one's a more nasty one. There are actually something called continued fractions, which are like infinitely big fractions, and they keep on going down and down and down and down. And this is kind of alluding to that. Okay, so you can write stuff like 1 all over 1 plus 1 all over 1 plus 1 all over 1 plus 1 all over 1 plus, and it could go on an infinite amount. Okay, those things exist. You can probably look it up on the internet. I am not fluent in that kind of stuff, but anyways, I think that's what they're getting at. The way I'm going to approach it is to simplify kind of from the bottom up. So I'm gonna kind of simplify this part here first, and then simplify this kind of part here, and then so you'll see what I do. Okay, so that part first, and that's pretty easy. I can just find a common denominator on it. So I need to multiply top and bottom by 9x here. So I'll have 1 all over, whoops, I want to go back to black. 1 all over 1 plus 1 all over 9x over 9x plus 1 over 9x. Okay. And then I can simplify that part by just combining the numerators over the common denominator. So we get 1 plus 1 all over 9x plus 1 all over 9x. Okay. Now I'm going to sort of rewrite that as multiplication to simplify it. So that'll be 1 all over 1 plus 1 divided by 9x plus 1 all over 9x. Okay. And then I'm going to rewrite that as multiplication. So 1 all over 1 plus 1 times 9x all over 9x plus 1. So that's easy to simplify. So 1 all over 1 plus 1 times that 9x over 9x plus 1 is just 9x over 9x plus 1. And then I need to find a common denominator here. So I need to multiply top and bottom of this fraction by 9x plus 1. Okay. And so I'll have 1 all over 9x plus 1 over 9x plus 1 plus 9x all over 9x plus 1. Combine the numerators over the common denominator. So I have 1 all over 9x plus 1 plus 9x all over 9x plus 1. I could rewrite that. Combining like terms, 9x plus 9x is 18x's plus 1 all over 9x plus 1. And then finally rewrite it as division. So I have 1 divided by 18x plus 1 all over 9x plus 1. That'll equal 1 multiplied by 9x plus 1 all over 18x plus 1. And then 1 times anything just gives you anything right back. 9x plus 1 over 18x plus 1. And that should be the answer. Okay, so you kind of work your way up from the bottom for those. I'm not going to put one of those on the test. 9x plus 1 all over 18x plus 1. And let's see what else they got for us. Okay, so they have some applications here. The average rate of on a round trip commute having a one-way distance is given by this complex rational expression to the right, where R1 and R2 are the average rates on the outgoing and return trips. So I believe R1 then is outgoing rate, then the return rate. Okay, simplify the expression, then find your average rate if you drive the campus averaging 60 miles per hour. So they're giving you an R1 of 60 and then an R2 of your return rate of 40. Okay, so first we need to simplify this thing. Okay, so we have d over R1 plus d over R2. Let me use the second method. So I'm going to multiply top and bottom by, well, I need an R1 to get rid of this R1, and then I need an R2 for that R2. Okay, so multiplying out, I get 2d times R1 R2 all over, okay, if I distribute here, in the first distribution the R1s will cancel, so you get d R2, and the second distribution the R2s will cancel, so you get d R1. Okay, and I believe that is our expression. Let's see if they have that. Oh, I can simplify it. I can factor out a d. So 2d R1 R2 all over d times R2 plus R1, and the d's cancel, and you get 2 R1 R2 all over R2 plus R1. So the distances don't really matter. Okay. And then they want us to evaluate this for our given value 60 and 40. So this will be 2 times 60 times 40 all over 60 plus 40. Okay. 24, it seems like it's 2400 times 2 all over 100. So 4800 all over 100, and then divide, I think at 48 miles per hour. We have a whole section dedicated to the story problems coming up. Not too far in our distant future. Okay, so another one, the bar graph showing revenue in billions of dollars for the music industry in a country from digital blah 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 fraction. We want to probably simplify it and then answer some questions. Okay. So yeah, in part A, simplify this thing. 1 plus 10. I'm going to use method 2. Multiply top and bottom by x squared. All over 7 minus 80 over x plus 530 over x squared. Okay. So on the top by x squared, x squared times 1 will just give you x squared. X squared times 10 over x, one of the x's will cancel, leaving you with 10x. And then x squared times 135 over x squared, the x squares will cancel. So you get plus 135. You do it to the top, you have to do it to the bottom. So 7x squared in the first distribution. The second one of the factors of x cancels. You get minus 80x. Plus the third distribution, the x squares cancel. You get 530. And then let's hope there's no I don't know if these things will factor. Let me get my calculator. 135. So I need two factors of 135 that add the 10. Maybe it's divisible by 15. Yeah, 9 plus 15. Nope. So what are some other ones? There's no way, because the numbers are going to have to be too big to be, they'll be greater than 10. So I think there's just no way. So let's go ahead and try it. You know, worst case scenario, we gotta do a little bit more work. Plus 10x plus 135 x squared minus 80x plus 530. Use the data displayed in the bar graph to find the percentage of the revenue from digital sales in 2009. So digital sales are the orange. 2009 is right here. And it says 3.3 billion. So what's the percentage of the revenue? The total sales. So I bet they just want you to take 3.3 divided by 7.8. So the 3.3 is the digital sales, and the 7.8 is the total sales. Okay, so that'll give you the percentage of the revenue. So 3.3 divided by 7.8, 0.42, round to the nearest percent. So it would be like 42.3% or 42%. Okay. Use a simplified rational expression to find the revenue from digital sales in 2009. Percentage of revenue from digital sales in 2009. So this thing is a mathematical model. Okay, the graph represents the actual data. Okay, so they're using this expression. They think they can make predictions with it. So they're kind of asking you to use the expression to make a prediction, and then probably compare part B and part C to how well they match up. Okay, so X is the number of years after 2000. So that's kind of our first issue, is just dealing with what is our X value. So X is, they want the number of digital sales in 2009. So we're going to have to go 2009 minus 2007. So X should be 2. And then we're taking the number 2 and plugging it into that expression. So 4 plus 20 plus 135 all over 4 times 7 is 28 minus 160 plus 530, and then just put it in your calculator and see what you get. So 155, 159 divided by, use some parentheses here, 28 minus 160 50 plus 530 in parentheses equals, so 0.399, but they want a percentage, so you have to move the decimal over 2 places, and then you get 39.9%, but then they want you to round to the nearest percent, so you add 1 to this position here, because this position here is greater than 5, greater than or equal to 5, and so you'll end up with 40% is your final answer, which is, I would say, kind of close to their actual data. It's an underestimate. It's lower. That means under. And it underestimates by 2 percentage points. Okay. Oh boy, this last one. It's just like a challenge problem. 8y all over 4 plus 4 over y, and then plus 12y all over 3 plus 3 over y. Okay, in both cases, I'm just going to multiply top and bottom by the y, and that should clear all the fractions out. Okay, so in the first guy, I'll have in the numerator 8y times y is 8y squared. Down here, 4 times y, and then y times 4 over y will just be 4. The y's will cancel, and then plus 12y squared all over, so y times 3 is 3y, and then y times 3 over y will just leave me with a 3. Okay. You can find a common denominator here. It might be a little quicker to simplify a bit. So in the denominator here, I can factor out a 4, and you'll be left with y plus 1. The second denominator, you can factor out a 3. You got y plus 1. And then you could, 8 over 4 is the same as 2 over 1. So you get 2y squared all over y plus 1. And then plus 12 over 3 is the same as 4 over 1. So you end up with 4y squared all over y plus 1. And then you automatically got your common denominator. So 2y squares plus 4y squares is 6y squares all over y plus 1. So that problem's not as difficult as it kind of looks. Anyways, thank you for watching as usual, and we will see you in the next video. Yay. Okay.